Welcome back, AI architects. As we move from simple AI pipelines to enterprise-grade systems, complexity skyrockets. Today, we are mastering subgraphs in LangGraph, the ultimate pattern for building modular, hierarchical architectures that scale safely and predictably. Let's get started. Let's define our core concept. In LangGraph, a subgraph is simply a compiled graph that is used as a single node inside another parent graph. Think of it like nested functions in traditional software engineering. Why do we need this? If you try to build a massive enterprise system with dozens of agents, tools, and routers in a single monolithic graph, it becomes a visual and architectural nightmare. It is impossible to debug and hard to maintain. Subgraphs solve this by allowing us to build modular architectures. You create a specialized workflow, compile it, and slot it into a higher-level process. The parent graph treats this entire complex workflow as just one standard node. It passes the state in, waits for the process to complete, and receives the updated state back, completely abstracting away the internal complexity. Take a look at this flowchart to see the encapsulation in action. Our top-level parent graph flows from the start node down to a standard node, and then hits the subgraph node, highlighted in blue. Notice the box below it, subgraph node internals. The parent graph is completely unaware of internal nodes 1, 2, and 3. It simply waits for the blue node to finish its execution and hand back control. This perfectly demonstrates modular encapsulation. Subgraphs are the key enabler for hierarchical multi-agent architectures. In enterprise environments, flat, monolithic agents fail when tasked with complex business processes because they suffer from context overload and instruction drift. Instead, we must structure our AI systems like a corporate team. We utilize a supervisor or orchestrator agent at the top level. This supervisor doesn't do the heavy lifting itself. Its sole job is to analyze the user's request, break it down into subtasks, and route the execution to specialized departments which are modeled as subgraphs. For example, if the user needs a market report, the supervisor routes the task to the research team subgraph. Once that subgraph completes its multi-step internal process, it returns the data to the supervisor, who then routes it to the writing team subgraph. This creates highly scalable, organized AI systems. This diagram visualizes a classic supervisor architecture. The user request hits the central supervisor agent. Acting as the ultimate manager, it delegates the work via conditional edges. It first routes to the data team subgraph on the left, which returns raw data. Then, it routes to the analysis team subgraph on the right. Finally, the supervisor consolidates all the subgraph outputs into a polished final output for the user. The most critical aspect of modular architectures is state management. How do we pass data across the boundary from the parent graph into the subgraph? The most straightforward approach is using shared schemas. If both your parent graph and your child subgraph are defined using the exact same Python-type dict or Pydantic base model, meaning they share the same state keys, integration is effortless. You simply compile the subgraph and pass it directly into the parent graph's addNode method. When the parent graph hits that node, it hands the entire state dictionary over. The subgraph reads the keys it cares about, runs its internal workflow, and returns a dictionary with updates. Because the schemas match perfectly, LangGraph automatically merges those updates back into the parent state. This class diagram illustrates the shared schema pattern. At the top, we have our shared state annotation, defining properties like conversation history and current task. Notice that both the parent graph and the child subgraph depend on this exact same schema. Because they speak the same data language, the parent graph can seamlessly contain and invoke the child subgraph without any data translation middleware. While shared schemas are easy, true enterprise modularity often requires differing schemas. Imagine you build a highly specialized math subgraph for your company. That subgraph shouldn't need to know about your parent application's user session ID or chat history. It should only demand a math equation. To integrate a subgraph with a completely different schema, we build a wrapper function in the parent graph. As shown in the sample code, this wrapper node acts as a data adapter. When invoked, it extracts the relevant data from the parent state, translates it into the keys required by the subgraph state, and calls subgraph.invoke. Once the child graph finishes, the wrapper takes the response, translates it back into the parent schema, and returns the standard state update. This allows maximum reusability of your subgraphs. Follow the sequence diagram to see the adapter pattern in action. The parent graph passes its state to the wrapper node containing global query. The wrapper node intercepts this, mapping the global key to the math equation key that the subgraph expects. The subgraph processes the equation and returns the result. The wrapper then maps the answer back to global query, cleanly updating the parent graph without schema conflicts. Once you master subgraph state routing, you can build the ultimate enterprise architecture, the network of experts. If you have a business process with 30 or 40 distinct tasks, even a standard supervisor architecture will fail because the top-level manager gets overwhelmed coordinating 40 workers. Instead, we nest orchestrators. The top-level agent routes to high-level departments. For example, it sends a task to the legal department. Crucially, the legal department is a subgraph that contains its own internal supervisor and several legal subagents. The top-level orchestrator doesn't care how the legal agents debate or search their internal databases. It only cares about the final approved or denied state output by that subgraph. By distributing the cognitive load across multiple tiers of orchestrators, we can build AI systems capable of running entire companies. Here is the network of experts architecture. At the top, the CEO orchestrator delegates tasks to the marketing department subgraph and the engineering department subgraph. If you look inside the engineering department box, it has its own autonomous ecosystem, an engineering supervisor managing a code agent and a QA agent. The complexity is beautifully encapsulated at each level of the hierarchy. Let's apply this to a critical, real-time use case, an enterprise loan processing pipeline. Originating a loan requires distinct, highly regulated phases, validating documents, checking credit, assessing financial risk, and ensuring policy compliance. If we bundle this into one monolithic agent, a failure in document validation might accidentally trigger a hallucinated credit approval. Instead, we use a modular solution. We deploy a loan orchestrator agent as our parent graph. We then build two separate subgraphs, a KYC subgraph for identity verification and a financial subgraph for credit and risk scoring. The orchestrator invokes the KYC subgraph first. Only if the state comes back with the isValid flag set to true does it invoke the financial subgraph. By compartmentalizing these risks into independent subgraphs, we achieve the auditability and safety required by financial regulators. Trace the execution of our loan processing pipeline. The loan application arrives at the loan orchestrator, which immediately invokes the green KYC subgraph. Notice the rigorous fail-fast routing. If the state returns invalid, it branches downward to reject the application. If valid, it proceeds to invoke the green financial subgraph. By isolating these critical workflows, the orchestrator safely guides the data toward the final compliance check. To conclude our masterclass on modular architectures, let's review the best practices. First, test your subgraphs independently. Because they are fully compiled graphs on their own, you can unit test your financial subgraph in total isolation without needing to spin up the top-level orchestrator. Second, avoid state bloat. When using wrapper nodes to map data, be surgical. Only pass the exact variables the child needs to prevent context overload. Finally, establish strict error boundaries. Implement your adaptive retry loops inside the subgraph, so the parent orchestrator only ever receives a clean success or failed status flag, keeping the top-level routing pristine. Mastering subgraphs is the definitive step to engineering robust, enterprise-scale AI platforms. I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Keep building. Our final diagram is a roadmap to success. Modular architecture mastery relies on three pillars: independent testing of subgraphs, state minimization across boundaries, and strict error boundaries. When applied together, these pillars converge, enabling you to deliver highly reliable, scalable enterprise AI systems. Thank you for joining.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice papers paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it, and you can move to the next question. Now, third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology-wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.